Hi everyone, today I'm going to present the paper called CloudFL, a zero-touch federated learning framework for privacy-aware sensor cloud networks. In traditional machine learning pipelines, the data is collected to the huge central server where the high computational resources are leveraged to train a machine learning model on the training data collected from the end devices. So this was sort of the traditional approach, which actually helped us to gain insights into how far we can go with the uh, high computational power and the huge amounts of data collected over the time. But this sort of created issues on the private data used from the end users. So the guidelines and the new laws are formed, which sort of prohibits the direct data transfer and emphasizes on encrypted format or other ways which can be used to utilize the user data but not directly transfer the user data to the central server. To address many of the concerns, the federated learning was being proposed over the years, and it is gaining popularity because of the model-centric approach it takes. So it proposes to pass on the model weights, train your own machine learning model at the end device, and pass on the model weights into the central server. So you can see in the slide a group of end users with the mobile data. They don't actually share their mobile data; they share the on-device trained machine learning model weights to the central server. So once the central server gets this model weights, it runs a FL averaging algorithm on this model weights and comes up with a model called a global model, which sort of have knowledge of all the individually trained ML models. So the global model is then passed back to the end users, and the end users will have an option to personalize it further by retraining it with the uh, personal copy of the data. Here are the list of contributions of our work. We are leveraging federated learning benefits by defining our own federated learning framework. This allows you to personalize a federated learning framework for your use case with minimum learning curve. So we have implemented our solution on cloud, basically AWS, which will allow to start off without waiting for any huge computational resources. All you have to have a in device where you can train your machine learning model and pass on the learned model weights to the central server. Here are the list of frameworks which are being proposed to implement federated learning. The first one would be PySwift or the PyGrid network, which was proposed on top of PyTorch. Second one is TensorFlow federated, OpenFL, and Fate. Here is our proposed solution, which uses Python socket IO to transfer the training machine learning models, and we have used crypto system Python's quantization logic to minimize the size of ML model, and pretty much it the overview of our proposed approach. The reason behind selecting our own Python framework instead of going for a dedicated federated learning framework is the existing frameworks is a bit of learning curve where you have to learn how to install, how to set up your environment on your use case, and it doesn't allow you to personalize the way you want things to be done in your federated learning network. So we sort of missed personalizing the options you have for training your machine learning model. So, and even the productionized version, you don't currently get support from the existing framework. So beta phase, most of the federated learning frameworks are in beta phase. They are also upgrading it and adding more features to it to make it much more usable. Here is the detailed view of our proposed approach. We have used Amazon EC2 instance as our central FL server, which connects to the FL clients deployed or configured on different end systems. We have a scheduler which triggers for the FL average process. This framework provides asynchronous updates. So you need not have your use case in devices to have a it don't force the end devices or poll the end devices. You have options to send the trained ML models from your end device to the central server asynchronously. So there is a scheduler which looks for the minimum amount of machine learning model updates it received at the central server, and it triggers FL averaging algorithms which creates a global ML model. So there are a series of events which gets triggered from there. So once the global ML model is done, the aggregation of FL model is done, ML model is done, it is sent back to the end devices. The reason for picking up Python socket type of communication or between the FL clients and the FL central server is it is not language specific. You can have any language on the client side, and it provides a microservice architecture for communication between server and client. So we have used Amazon EC2 as our central server, and we have leveraged PyTorch deep learning framework for training the on-device and central server machine learning ML models. We have used Python socket type for communication between the end devices and the central server, which is an Amazon EC2 instance. Here are the set of the rules which are defined for each FL client, the end devices in the FL network, which are completely personalizable based on the use case you have. And here is a guidelines on how the training is triggered. The end users have the flexibility to send the on-device trained machine learning model weights to the central server asynchronously whenever there is a flexibility, enough bandwidth, and the battery life on the end device. The network doesn't force any timings or any limitations on how many times the updates are being sent. It provides a flexibility to the end users. We have used a quantization technique to reduce the model size so that the network bandwidth need not be more to transfer the model weights. We have a scheduler. We have a EC2 instance which does a major part of aggregating the model wells, and here are our experiment results with the sensor cloud data set and our future. To summarize, we have proposed a federated learning framework, the personalizable federated learning framework which you can use for your use case with the minimum learning curve. And we have used a PyTorch deep learning framework. As part of our future work, we would like to use other deep learning framework like TensorFlow, which can leverage our framework, and the end users can build their ML solution on any deep learning framework. Still, it can leverage our framework and share the model weights from the central server. Yeah, that's all for today. Thank you for listening, and have a good day. Thank you.